Welcome back, everybody, to our next webinar. I'm really happy to have you here for the next session. I've got a webinar prepared from Rogier de Klein from AMCS Group, and he will talk a little bit about how forecasting algorithms and the Internet of Things are already revolutionizing our waste collection, and especially what will happen in the next years when our cities grow even smarter, and which impacts this will have on waste collection and the industry at all. And yes, I can only say have fun with that. Thank you for being here, and let's go.
Good afternoon. Today we have a presentation about smart cities and more specifically about smart city waste collections. And we'll have a look at how innovative technology can be used for optimization of waste collections. I have a brief agenda. First, a brief introduction, looking at some trends and challenges. Then we'll look into various types of technology solutions or IoT devices that can be used in waste collection, followed up by an explanation of how forecasting and the use of algorithms can lead to more efficient waste collections. Then how all that is combined in an end-to-end solution to automate the entire process. Then we'll look into some unique features and unique aspects to this solution. And to wrap it up, we'll discuss some major results that some of our customers have achieved, and also show some case studies on that. My name is Rogier de Klein. I've worked for AMCS for 8 years, mainly in the field of intelligent optimization solutions. So that's a bit on my background. And to dive into it, I'll first run you through some major trends and challenges that we have identified over the years working in this field. One of them is very obvious and something that you'll probably recognize, is that there's an ongoing push for a more circular economy, in which the main challenge would be to collect more reusable materials, which obviously requires waste separation and a different way of collecting the waste, often referred to as reversed collection. A second one is that if we introduce new ways of waste collection through, for instance, underground containers, we'll look into a bit later, how do you maintain service levels? So how do you make sure that you collect all waste in a timely way or timely fashion, with minimal nuisance for the citizens in the city? And a third one would be efficiency. Obviously, doing all this, a main aim to chase is doing it as efficient as possible, and that is all about making best use of the assets that you have available. That means containers, that means vehicles, but obviously also your employees, making sure that they are as productive and effective as possible. So one of the main ways of securing waste separation and making sure that we have more attractive cities and all that is through placing waste underground instead of above ground, and that is done through underground containers. You see an example here on the right, where we have a large waste container sitting underground, which you don't actually see. But we do have a column above ground with a valve in there, which allows for the disposal of the waste. Typically, these are set up to be containers to collect waste of a certain fraction. So you would have various containers for various fractions, and they are large because they have to collect the waste of various households surrounding it. So that's a bit of an introduction into underground containers. If you then look into what challenges, new challenges they introduce in terms of collection, it's obvious that these things need to be pulled out of the ground, so it requires collection with crane vehicles, and obviously it's very difficult to determine how full a container is and to determine when you would actually want to empty it. So that's a bit of a challenge there. Typically those would be collected on a fixed pattern. If you don't have any technology, you try to actually forecast how quickly a container fills and then decide upon a frequency of visiting the containers for emptying. But we are trying to look into smarter ways of doing that in this presentation. And obviously, with these large vehicles required to do the collection for them, it's also important that you take into account that you possibly don't want or are not allowed to visit certain containers or sites during certain opening hours, or for instance, if there's a school, you don't want to go there when the kids are just going into the school, right? And similarly for a market, and you may possibly want to take into account certain hours of the day having heavy traffic in certain areas. So that brings additional challenges to organizing the collections in an efficient way. So first, to dive into the technologies we have available out there and how to use them to determine when to collect containers. In other words, how to determine when they are full. Basically, three types of solutions out there. The first would be an access control system, which basically means that a citizen needs to present a card to open the container and then can get his waste disposed, right? The system then registers the number of times the valve was opened, and that is then translated into a filling degree. So the reasoning behind it is each opening of the valve represents one bag of a certain volume or weight, and that is then calculated towards a filling degree. A second technology would be through an ultrasonic sensor that actually measures the volume of waste that sits in the container at a given point in time. So that is actually a way of looking into the container, if you like, and see how much is in there. A third technology that is used is weighing, and that is done on the truck. So when a collection vehicle goes out to collect the waste from an underground container, it lifts it, and when it has the container hanging on its crane, it weighs how much weight there is on the crane, and that is also a way of determining how much weight you collect, how much waste you collect, if you like. So how can we use that information to determine when to actually go out and empty the containers? And that is done through an end-to-end process, if you like, that starts with forecasting. And forecasting is a process with which we try to determine how quickly an underground container fills up and how we can use that information to determine when to collect it. And that runs through a cycle, and that starts basically by collecting historical data of filling degrees over time, so that you can basically build up per container or per site a filling degree forecast pattern, which typically looks a bit like a jigsaw, and that is well, roughly shows the typical pattern of a container filling up and then being emptied again and filled up again. That data then sits in our solution, and we start the actual planning and organizing of collections based on this by actually measuring the filling degrees, either through the sensors or the access control systems. We get actual filling degrees into our system. So that's the IoT device doing its work. And the filling degree information flows into our system, into the forecast part of the solution, to determine the time of collection. Right, so we know how quickly a container fills up based on the forecast. We know how full it is now, so we know how long we still have to go out and collect the waste from it. That's basically the principle behind that. That is then used to automatically generate collection orders, and typically we do that in with creating two types of orders: must-dos and can-dos. Where the must-dos need to be done the next time a truck is sent out, and can-dos can be combined into the routes with the must-goes to make the whole plan more efficiently. You can imagine that it's much more efficient to take a container that is maybe a bit less full than a must-do, but it's more efficient to take it now than send out a new truck the day after. Right, so we take that one because for the whole planning, it is more efficient to take it now. So that's the order generation. Must-do and can-do orders are automatically generated based on the time we still have left for it to be collected, for the container to be collected. And those orders then feed into our optimization engine, and that basically creates optimized collection routes for a fleet of vehicles. And it does so based on the real-time data that is available. So that's the entire process of using IoT and forecasting to optimize the waste collection. Just in a bit more detail, this is the jigsaw, but then in a much closer look at it. So what we're looking at here is basically, you see the last time of collection, which is when the filling degree drops to 0. Then we have a forecast graph building up the filling degree of the container, and on that is plotted a current filling degree, because at that point in time we get the signal from, for instance, in this case, the ultrasonic sensor, and it says the container is this full. So then we are capable of adjusting the forecast graph, if you like, to show that we are either running behind or ahead of when we think we need to collect the waste from the container. And that helps us to determine when the container needs to be a must-do order and when it is a can-do order. So that's how we use the forecast based on the historics, as well as the current fill level data that is available to generate the orders, if you like. If you then look at how to combine all this into a solution, this is basically what we offer to our customers that aim to optimize their underground waste collections using the IoT, and these components come into play. And first of all, it's very clear that we need to set up something like resources. We need to understand which drivers and which trucks are available to us for doing the collections. That is basically necessary information for the solution to work. Another clear aspect is that we have that forecasting in there, and the forecast basically serves as an order generation tool based on that historic data, building up that forecast profile, but obviously also taking its information from the IoT devices that are connected to it. So there's the ultrasonic sensor, for instance, or the access control system, which actually tells the forecast part of the solution how full the actual container is. That leads to those must-go and can-go orders that flow into the optimization part of the solution. Obviously, that is used for automatic planning and optimization of the collection routes. And part of the end-to-end solution is also a mobile solution, which is used by the drivers, so that the actual optimized routes and the orders can be communicated to the drivers, and that the drivers in real time are connected to the back office, so that also in the back office people are aware of how we progress in the collections out in the field. And that allows, for instance, for a real-time insertion of an ad hoc order, because we know exactly which truck is the most suitable one, given how far they are with their planning. So that's the entire landscape, if you like, and that all works together as an end-to-end solution to support this IoT-based collection process, if you like. So that leads to a number of differentiators for this solution, if you like, and one of them, and one is very important, I think, is flexibility. Through the IoT layer, we are capable of connecting any sensor or any access control system from any vendor to our solution. We have existing integrations with many of them, and it's built to be a flexible layer to connect external vendors and devices to our solution, which means that basically whether you have 1 or 3 vendors for these IoT devices, maybe all with their own backend software solutions, we don't care, we can integrate to all of them and provide you with one solution for optimization for the entire fleet, for the entire collection area, no matter how many devices are in the containers and from how many vendors. It's a true end-to-end solution. So that's another differentiator. It integrates the forecasting, order generation, resource management, planning and optimization, even execution and monitoring. It's all being done in one integrated end-to-end solution. And that's pretty unique if you go and look in the market for solutions like these. Also, it's unique in the level of complexity it can handle. Typically, we're looking at a planning that covers multiple trucks that each have to be collecting multiple containers. So that means many ways of planning that. And there's a lot of restrictions and complexities that need to be taken into account that come from the resources. You may have various types of containers, types of vehicles. The vehicles and drivers are on certain schedules. In the day of work of these drivers, we need to cater in for breaks. We need to take into account the working hour regulations. Also on the order side, there's all kinds of complexities that certain containers can only be served in certain service hours, for instance, in case of schools, markets, etc. Trying to combine must-go and can-go orders in a meaningful way in your planning can be quite a complicated thing as well. And what we see is that quite a lot of waste collection companies are actually collecting the waste from several municipalities at the same time. So that brings additional complexities in planning, but also in allocating collected weights of the waste to the correct municipality, for instance. Planning across multiple trucks is a complicated matter in itself, but doing it so dynamically based on real-time filling degree data means that you do it in real time as well, which only adds to the complexity, obviously. And our solution is built to handle all of this, which makes it stand out as well. And then as a last unique differentiator, if you like, it's actually something I just mentioned. It's all about allocating the correct weight to the correct municipality based on that we know with our solution, based on the real-time capabilities, based on the mobile solution the driver has, that we know exactly the amount of waste that is collected where, and that allows us to basically accurately allocate that waste to the municipality that you actually performed the collections for. So that's a bit on the challenges, on the technology, on ultimately on a solution that hopefully enables you to manage all those challenges and through use of that technology. But ultimately, what does it bring is maybe the most interesting part, and I think that speaks for itself. Truly does. We've had customers that started this journey a couple of years ago and have some very solid results on this. And two of those examples are Twente Milieu and Omrin, and they are presented here on this slide. Twente Milieu first. It's a company about that actually collects waste in 6 municipalities in the east of the Netherlands, roughly just below 200,000 households by now. 1,400 underground waste containers, and by basically using IoT, using the dynamic collection solution that we've offered them, they have been getting some great results out of that, and that starts with basically making much better use of the underground containers. We've seen that the average filling degree at collection has moved from 50% to over 80%, even over 85% at some point in time. But some of the containers have been put on a frequency again, which basically means that the average filling degree has slightly dropped again, but it's still way over 80%, which obviously is still a massive increase over the 50% it was when they started this. In terms of productivity, they have increased the volume collected per hour by more than 25%. That means basically a truck and their employees are over 25% more productive when it comes to collecting waste, right? So that's a massive increase as well. This all has resulted in a much more efficient operation. They need to send out trucks only when the containers are full. Because of that, they do less containers, but they collect more waste when they actually do a container or empty a container. And that overall has resulted in a big reduction in mileage and numbers of trucks used. Initially, they could even park a couple of trucks, but overall, they've seen a reduction in mileage of 35%. And the big one as well is that because they serve municipalities and they are owned by those municipalities, a big thing for them was the service levels and making sure that absolutely no container overflows anymore. And that's also a way of, or that's something that IoT helps you to do, because you actually know how full a container is and determine your collection based on it. It is also a way of preventing overflow of the containers and coming too late to collect the waste from it. So that's something you prevent by this as well. So it's not only efficiency, productivity, it's also that service level side that you actually serve with this. So we have publications around that. That's shown there. So there's more information for you available if you're interested. Go to amcsgroup.com and you can find the press release or whatever it is. Then Omrin, it's a company in the north of the Netherlands. It's also a company working for several municipalities, 18 in this case, over 200,000 households. They have been awarded the most sustainable company in the Netherlands in 2019, which shows that they are actively investing in all kinds of ways of optimizing their service towards sustainability. And they have worked with the solution for the last couple of years, and similarly to Twente Milieu have very impressive results. Filling degrees from 60% also to over 80%, and still improving. because they are still finding the limits, if you like, of where they can go. Improve productivity in terms of they have an increasing number of underground containers. So more and more waste gets collected through underground containers, but they haven't had the need to add additional trucks because they make better use of them. Similarly to Twente Milieu, service is an important part. Omrin, like Twente Milieu, doing the services for 18 municipalities, need to make sure that they offer a reliable service, and that's something they've been able to do, and that's stabilizing and improving their service, while at the same time doing it with less miles, stops, less fuel consumption, less CO2 emissions, less investment in new vehicles if they add containers. That makes for a very strong case at Omrin as well, of which we have also made a publication which you can find on our website. So yeah, all in all, I think there's very much potential for optimizing waste through the adoption of IoT and using smart forecasting algorithms basically helps to maximize the effect of that, maximize the results out of the IoT adoption, and that's hopefully something that you take out of this presentation. Obviously, there's many more areas where you could think of applying IoT. That's why I mentioned an IoT layer. It's a very generic concept. I've just focused on how IoT is used for determining filling degrees in this sense, or in this case, but you could think of other areas as well. And that's something that we are actively developing for as well. And that was my presentation for this afternoon. So thank you for listening. Please contact me at rogier.deklein@amcsgroup.com if you have any further queries, or if you want to brainstorm a bit on how this could be beneficial to, for instance, your company. I'm more than willing to do that, obviously. So please feel free to contact me. Thank you very much.
Thank you very much for that presentation from AMCS. Thank you all for joining today, and I would love to have you back in our next webinar, which is starting in approximately around 15 minutes at 5 p.m. And we will hear a little bit about digitalization and sustainability, this time not from the Netherlands, but from Asia, with, let me have a quick look so I pronounce it hopefully correctly, Mr. Kian Shaw, and from Heng Hiap Industries and the Circular Economy Club. So everyone, nice to have you, and see you back in 15 minutes. Till then, bye-bye. Thank you so much. Head over to the booth from AMCS if you need any further information, if you want to get in touch with them. Have fun. Bye-bye.